with Ortegren, and I am supposed to present homework 1, problem number 7. It's the one with the strikeouts. I think you remember it. And so I looked at the problem this way. We had 4 pitchers, so I thought of it like 4 lines. And I know that they're going to add up to 297 strikeouts, and so I just thought of them like piles of strikeouts. And so the question is, how many are in this top guy's pile if you pile up all the strikeouts? Least amount and most amount. So to get the smallest amount in this pile, obviously these 3 piles need to be as large as possible, and vice versa for the largest amount. So let's start with the largest amount. So what's the most strikeouts this guy could have? Well, I know that there's a least amount for these piles. The smallest I can make these piles, I want to make them as small as possible, but there's a restriction in the problem that they have to be 40. The smallest they can be is 40. So if I fill these piles with 40 strikeouts, and do the math there, that's 120, subtract that from that, that means this guy has 177. So if these piles are as small as possible, that leaves the most strikeouts from the 297 here. So the most that our guy can have is 177. Now the other way around, obviously I want these piles to be as big as possible, leaving the smallest amount in this guy's pile. Now keep in mind that he still has to be biggest, or I allow ties, obviously, so he has to be tied for the biggest. And the uppermost restriction we have is that this least guy, this guy down here, the most he can have is 49. So if I fill him up as high as I can, we still want to add to 297. If I fill him up as high as I can, that gives him 49. So now we're in a little bit of a dilemma because I don't know how full I can fill these guys. So I thought of it like this. If I make them all 3 equal, then I want him just to be either equal to the most or 1 more than the most. So if you fill up all the piles equally, divide this by 297, that gives you around 83. So if I make him 83, obviously he has to be either tied or less than that, so let's make him 82, which works out this guy's 83. So I actually have 2 guys tied for the most, but that's okay. It doesn't say that he has to be by himself at the most. And if you add those together, you get your 248, which was 297 minus 49. To make sure that's right in my head, I think, well, is there any way that I could take some away from this guy and add it to another pile? Well, we know we can't add it to this guy, because that would be 49. That's the most he can have, so that added to 50. So if I took some more away from this to get it less, let's say I wanted to get it 82, then I would have to add it to another pile, which make this guy not have the most, or tied for the most. So the least amount that this guy could have is 83.
Oh, that's all you need.